This lesson is on polar coordinates, which is a new way we have of identifying the location of a point on a graph. So our regular way of identifying a point is just to figure out the horizontal distance from the origin, and that's our x. So for this point here, that would be 4. And then find the vertical distance, which is our y. In this case, that would also be 4. Those coordinates there are actually called rectangular coordinates. We don't usually call them that because we usually don't think of there being an alternative. And that's what we're going to use most of the time is rectangular coordinates. And we do have this second system called polar coordinates that has its uses. And the idea here is the origin of the graph, we think of it as a pole, like the North Pole or the South Pole. And then the points radiate outward from that pole. So the two coordinates of your polar coordinate system are r and theta. R is the distance from the origin out to the point. And it's called r because like the radius of a circle is the distance from the center of the circle out to a point on the outside of the circle. This is the distance from the center of the graph out to the point. So that's why it's r, because it's related to a radius. So distance from origin. Now, when we go from the origin out to this point, we have kind of this imaginary line, this r line that we make, and that creates an angle with the x-axis, and that angle is our second coordinate. So the second coordinate is theta. And I'm just going to write angle formed with x-axis. So in rectangular coordinates, x and y are both measurements of distance, but in polar coordinates, r is a measurement of distance, but theta is an angle that we can do in radians or degrees. So let's look at some examples and see what we're dealing with here. First, we're going to plot points using polar coordinates, and these two examples involve degrees. The first one is 4, 150 degrees. So what I want to do is make this a 150 degree angle. I'm going to make my initial side on the x-axis, and then I find 150 degrees, and I make my terminal side. So that's a 150 degree angle. And then I want to go outward from the origin 4 units. So I start in the middle, and I go 1, 2, 3, 4. So the distance along that terminal side out to the point is 4. So this point out here is the point 4, 150. Let's do one with a negative angle measurement. So here we have negative 120 degrees. I'm still going to start on the positive side of the x-axis. Quick review on negative angles. A good quick way to find the location of a negative angle is to subtract that number from 360. 360 being 1 full rotation. If you subtract those, you get 240. So negative 120 would put us at the same place as positive 240. So I'm going to make my terminal side there. So that is my angle, negative 120 degrees. I'm going backwards around the circle this time. And my r coordinate is 2, so I'm going to go out 2 from the middle, and that's going to put me right here. So that right there is the point 2, negative 120. So that's how you plot polar coordinates with degrees. Let's do a couple with radians. It's going to work the same way here. The first one I have is 3, 7 pi over 6. So I find my angle 7 pi over 6. It's right here. So that's my angle right there, 7 pi over 6. And then I'm going to go out 3 spaces from the center. So 1, 2, and right there. So that's my point, 3, 7 pi over 6. So not really a lot of difference between radians and degrees here. This last example is a little trickier, though, because we have a negative number as our r. So I'm going to start by identifying the angle first. And they don't put pi over 4 on this graph here, but it's going to be right there. So pi over 4 is right there. So that's my angle, pi over 4. And then my r is -2, so I have to go out -2 from the center. Now, if I started going this way, that's a positive direction. So if I go outward on the terminal side here, I'm only going to get positive numbers. I have to have a way to go backwards. So what I do is I kind of imagine extending my terminal side backwards, and I go 2 in that direction. So I'm going to go 1, 2, and it's going to put me right there. So that's -2 pi over 4. So now you have a negative number. Just extend your terminal side onto the other side of the origin. Another way you can think of it is you're like reflecting it, reflecting that point to the opposite quadrant. But that's how you'll do negatives, is you're going to go backwards from the origin. All right, this is where it gets a little trickier, changing from polar coordinates into rectangular coordinates and vice versa. The first one we have here is the point 2, 330. And I'm going to go ahead and put that on the graph here. So 330, we're going to go all the way around here. And my r is 2, so that's going to put me right there. So that's the point 2, 330. I want to know it's like regular XY coordinates. It's rectangular coordinates. So the first thing I want to do, step 1, find the angle on the unit circle. So I go to my unit circle. I find 330 degrees. I look at its coordinates. The coordinates at 330, I don't know how well you can see that unit circle, but we've done this before. It's square root of 3 over 2 and -1/2. Now, the whole idea with the unit circle is that it has a radius of 1. So on a circle with a radius of 1, if r was 1, those would be the coordinates. But on our point, r is 2. So the idea is you have to go out twice as far. So what you do is you just take these coordinates and multiply them by 2. So it's going to become 2 square root of 3 over 2 and -2 over 2. Now we can simplify these because these 2's are going to cancel each other out. We're going to end up with square root of 3. And a -2 over 2 is going to be -1. So the xy coordinates of this point would be square root of 3, -1. So what you do is you find that angle, you find the coordinates on the unit circle, and then you just multiply by r, by that first coordinate. So second example here is in radians. We have 3 pi over 4. That is right here. Again, it's not marked, but that's where it is. And the r on this one is 3, so we're going to go out 3 spaces. We're going to be right here. So we have 3 pi over 4, we go out 3. So again, find 3 pi over 4 on the unit circle. It's right here. The coordinates now are negative square root of 2 over 2 and positive square root of 2 over 2. So what we want to do again is we want to multiply those by r, by 3. And this is going to become -3 square root of 2 over 2 and positive 3 square root of 2 over 2. And we can't simplify anything there, so we're done. So that's how you go from polar coordinates to rectangular coordinates. I think going the other way is where it gets a bit harder. And I'm going to explain this the best I can and kind of walk you through how I think through these. So it says the first step is to find a factor you can multiply by a pair of coordinates on the unit circle to get your rectangular coordinates. So what I'm talking about is if you look on the unit circle, you've got stuff like square root of 3 over 2 and 1/2. You have square root of 2 over 2 and another square root of 2 over 2. 1/2 and square root of 3 over 2. So you want to think about those coordinates, and is there a way you could multiply a number, a factor by both of those, and get a certain pair of rectangular coordinates? So here on our first one, we have 3 over 2 and 3 square root of 3 over 2. So they're both positive, so I'm in the first quadrant. And I'm looking at the pairs of coordinates in the first quadrant, and I want to see, is there a pair of coordinates I could multiply by a single number and get that? So I see the first number does not have any square roots. The second number has a square root of 3. So I'm looking right here at pi over 3, because what I've got is I've got 1/2, and I've got square root of 3 over 2. And what I see is if I take those two things and multiply them both by 3, then I get 3 over 2 and 3 square root of 3 over 2. So the idea is I'm taking my coordinates at pi over 3. So pi over 3 is my theta, that's my angle. And I'm multiplying both coordinates by positive 3 to get those numbers. So my polar coordinates of that point is going to be 3 comma pi over 3. So figure out which set of coordinates on the unit circle this is based off of. Figure out what you would multiply by to get to your rectangular coordinates. And that's going to tell you what your polar coordinates are. So let's look at another one. We have -3 square root of 2, positive 3 square root of 2. So the x is negative, the y is positive. So we know we're in the second quadrant because that's where x is negative and y is positive. We also see that these two numbers are the same except for the sign. They're both 3 square root of 2. So the only place that happens, the only place where the x and y have the same absolute value in the second quadrant is 3 pi over 4. So we know our theta is going to have to be 3 pi over 4. Now what we have to figure out is, what do we multiply by? The original coordinates are negative square root of 2 over 2 and positive square root of 2 over 2. What would we multiply by those to get -3 square root of 2 and positive 3 square root of 2? So the way I think through this is we've got to cancel out those 2's. So to cancel out the 2's, we've got to multiply by a 2. After the 2's are canceled out, we have these 3's that come in. So those got to come from somewhere. So we also have to multiply by a 3. So to make this work, we're multiplying by 3 and 2, and 3 times 2 is 6. So if you take 6 and multiply it by the coordinates at 3 pi over 4, you will get these coordinates right here. All right, so the number we're multiplying by is 6, and the place where we found the coordinates was 3 pi over 4. So those are the polar coordinates, 6, comma 3 pi over 4. So I think this is the hardest thing we're doing with polar coordinates, is going from rectangular to polar. So we can go over this some in class on Wednesday too if you're struggling with this. This I do think is the most difficult thing. We do have one more thing to go over though, and the last thing we're going to go over is finding distance. I've got this residual ink here on the slide, but don't worry about that. We're going to find the distance between polar coordinates. So what I want to do is I'm going to plot my 2 points here. I've got 2 pi over 6. So I'm going to find pi over 6. I'm not going to make the initial side on the x-axis. We all know that's there. And I'm going to go out 2 spots. So it's going to be right there. So that is 2 pi over 6. All right, my second point is 2 pi over 3. So 2 pi over 3, I see that's right here. I'm going to go out 3 spaces, 1, 2, 3, and make a point. So that's 2 pi over 3. So those are my 2 points. What I want to do now is make a triangle. So I'm going to connect the 2 points. The reason I'm making a triangle is because what I'm looking for is this line I just made, the distance between the 2 points. I'm going to call that C. So that's what I'm trying to find, is that the length of that line between the 2 points. And right now on this triangle, I know that the side down here on the right is 2, because I went 2 out from the origin. The side over here on the left is 3, so I got 2 and 3. And then I also can figure out this angle here. And the way I can figure out the angle is I can subtract the two angles in my polar coordinates, because I know this angle is going to be the difference between 2 pi over 3 and pi over 6. So I'm just going to subtract those. Find a common denominator. It's going to be 6. So this becomes 4 pi over 6. I'm going to subtract those. I'm going to get 3 pi over 6, which will simplify to pi over 2. So my angle here is pi over 2. The reason I needed that angle is because now that I have that angle and I know the other two sides, I can do law of cosines. Now, one thing you may have noticed is my angle is pi over 2. Pi over 2 is actually a right angle. And so because I have a right angle, I could actually just use Pythagorean theorem and be done with this a lot more quickly. However, that's rarely going to happen on the problems we do. So to help you be ready for the types of problems where that doesn't happen, we're just going to forget that we can do that and use law of cosines. So setting up law of cosines, we have c squared. C is the side that we're looking for, equals a squared plus b squared. A and b would be the two sides that we already know. So 2 squared plus 3 squared. And then we have minus 2 times a times b. So 2 times 2 times 3. And then times the cosine of our angle, which is going to be pi over 2. So law of cosines. So we work this out. 2 squared is 4, 3 squared is 9. 2 times 2 times 3, 2 times 2 is 4, times 3 is 12. And then cosine of pi over 2. 4 plus 9 is 13. Cosine of pi over 2, you can put that in a calculator, make sure it's set on radians. But that ends up being 0. And then actually, we've got the rest down here in purple. So 13 minus 12 times 0 just becomes 13 minus 0, which is 13. Remember, though, this is c squared. So we do have that final step of square rooting that number. So we have to take the square root of 13. And I'm just going to do that on the calculator over here on the side. Square root of 13 is approximately, if we round to the nearest hundredth, is approximately 3.61. So the distance between those 2 points, whose location we only know through polar coordinates, is going to be 3.61. So to find distance between polar coordinates, make a triangle using the two r values as two of your sides, and then the distance between the points as your third side. Identify that angle by subtracting the two angles in the polar coordinates, and then use law of cosines. So there you go. That's the stuff we are doing with polar coordinates.